All right, here we go. So welcome everyone. Thanks again for joining us today at another storage provider meetup. Today we have a great agenda as always. This time we have an update from the Filecoin Foundation on how to engage as a storage provider with verified clients. That has been a question that has come up multiple times in the last couple of weeks, and I thought it would be interesting for the team in the community to get an update on that. Second, we will have NVIDIA present today. Chen Long actually is going to talk about how to use the NVIDIA SSD or InfiniBand solution for SSD pooling, specifically in a Filecoin environment, which was tested and implemented by one of our Filecoin storage providers. And today he's going to share the information and how you can save on performance and cost, etc. And then last but not least, Intel. We have one of our storage providers joining us today called StorSwift, who's going to talk a little bit more about how the Intel, some of the latest Intel processors are utilized in his environment to run a Filecoin environment. So great stuff today, as always. Just a reminder, we do these meetups every single month. If you have any questions, topics you would like to see, please don't hesitate to put them in the chat or contact us through one of our channels, our Slack channels, or open an issue in GitHub. We're monitoring the full community, so please reach out to us and reach out on our GitHub community page. All right, let's get started. Let's go to topic number one, the Filecoin Foundation. So today what we'll have is we'll have with us, let me share my screen, just a second. We'll actually have Deep, very famous Deep, and Galen from the Filecoin Foundation walk us through an overview on how to engage as a storage provider. Give me 1 second. There we go. All right.
Galen, McAndrew with the Filecoin Foundation, recording this for the September 14th Filecoin Community Meetup. The timing conflicts with our regularly scheduled Filecoin Plus Notary Governance call, so can't join you here today in person. Sorry about that. But Deep Kapur from Protocol Labs, and I wanted to put together this presentation about how existing storage providers can engage with verified clients. Before we jump into that, I'm going to do a short overview of the Filecoin Plus program, just to make sure everyone's up to speed. So at a very high level, Filecoin Plus adds a layer of social trust to the network to try and incentivize youthful storage. You can read a lot more about this in the Filecoin Plus docs on the main docs.filecoin.io page. There's a section under storing that goes over some of the concepts, the different players in the space, and also gets into some of the steps about getting data cap and then how specifically you would spend that data cap and the various commands. So a very useful resource here. Please go check it out and let us know if we are missing anything in that section. So as you saw there, the core mechanism works by entities playing a variety of different roles. And so at its core, notaries are basically applying through community governance and working with the root key holders to get a grant of data cap, which they can then allocate out to clients. And those clients are then able to deploy that data cap to the storage providers in deals. So a little bit more about data cap. This is a resource within the network, as I said, that goes from notaries to clients. And they are using data cap to make these deals in addition to fill based on the deal price. As clients are using data cap, it is consumed. It's a single-use credit. And at this time, data cap cannot be transferred between client addresses so that it is flowing just from notaries out to a specific client address. And the way that it works for storage providers is they will receive extra rewards on the network for serving deals made with data cap. So to jump into some of those specifics, at a very high level, I think a lot of you understand how the incentives for the network work. in general for storage providers. The power that a storage provider has is determined by the quantity and the quality of their sealed sectors on the network. And storage providers can earn additional revenue from clients in addition to their block rewards by storing data. For example, the deal price that they get as clients pay that deal price over time. There's also an incentive to storing useful data that is getting retrieved at a high frequency to increase retrieval deal pricing. And both of these come with some additional liabilities that are offset by the price. That said, in the Filecoin Plus program, storage providers see a 10 times boost to their quality adjusted power for verified sectors. And so that increased power can lead to an increased likelihood of earning block rewards compared to sealing unverified deals. Additionally, as you work with vetted clients, there's a decreased risk of liability. These clients have gone through the process of working directly with notaries. There's more KYC happening. And so with those incentives combined, we're currently seeing 0 or very low fill deal prices from storage providers to clients. So then the question becomes, as a client, how do you receive data cap to begin with? We currently have 3 different mechanisms based on the size of deal, the size of data cap. So there's the first, which is a almost instant allocation using our auto notary at verify.glyph.io. With this process, you'll authenticate with your GitHub account, and you can receive 32 gigabytes of data cap, typically in less than a minute. This is a great starting point for clients that maybe are new to Filecoin, or for storage providers that wanted to test out sealing deals and getting data cap as a process. From there, we have a much more common flow, which is the general verification. This is currently the path that most clients go through. They work with an individual Filecoin Plus notary to get an allocation, usually somewhere between 0 and 50 terabytes of data cap. This happens after the notary and the client work together to perform some amount of due diligence. And notaries themselves have a say in what they require for their due diligence and what process they use. These notaries sometimes operate in a specific region, a geographic region, or in a specific field of work, a type of data that they most closely audit. From there, we have our very large scale. These are in the petabyte range for allocations, and the current process puts these applications in front of the entire Filecoin Plus community of notaries to help audit and vet how they are allocating and sealing deals, as well as their data source. And this is to get large amounts of data cap allocated over time. We currently have a number of those applications that have been approved and are currently allocating deals. And we have about 20 total that are in the application process overall. So then it becomes a question of what ways do you as a storage provider have to do your own outreach and find these verified clients? So right now we have 2 good mechanisms that I can talk you through, as well as some things that we're working on. We have a storage provider table where you can add your details for clients to find. This lives on our Filecoin Plus registry at plus.fil.org. When a client lands on this page, they can use this portal to get verified to begin with, as well as finding a storage provider. So landing in here, we have our storage provider table where they have the various contact information, locations, names. And if you are a storage provider and want to get added to this table on our Filecoin Plus client onboarding repo, which is a public repo, you'll see our miners.md markdown file, and you can submit a pull request to be added to this table. We also pull in some additional information, such as a reputation score. This is currently coming from filrep.io. So if that's of interest to you, please go submit a PR and get yourself added to our storage provider table. On top of that, we have two good public Slack channels where storage providers can do some marketing and outreach to verified clients. So there's the hashtag FIL-plus, that's our Fil Plus channel, and the hashtag FIL-deal-market. Both of these channels have a pretty wide audience, and on them you'll see various announcements, questions, tools that people are developing, as well as clients reaching out specifically asking to be connected with storage providers. And in this way, we have seen some really good community engagement. So go check out those two channels and feel free to add some marketing and outreach. But we know that we can do some more to help. So we're working on some upcoming improvements because it is important to us to help increase your marketing and biz dev opportunities. So we want better deal brokering for our verified clients and our storage providers. So the next thing that we'll be working on implementing is a process for clients to opt in to that outreach. And so the way that we're imagining this is on that direct data cap application, when a client is submitting an application to a notary, they will be able to check that they would like to opt in to that communication. Once we have that implemented and launched, we'll be able to put together another video like this presentation, because we want to help show storage providers how they would be able to search for those client applications, knowing that they're finding applicants that have already been granted data cap and are ready to start sealing deals. So we think that this new improvement, which we're anticipating in the coming months, will help increase the mechanisms for storage providers to find those verified clients. So next steps for you guys, we would love for you to join the Fil Plus community. You can participate in issues and discussions on GitHub. There are our various client onboarding repos and other Filecoin Plus project repos, and join our governance calls. These happen every 2 weeks. If you check out our notary governance repo, you'll find our most recent issue announcing the next notary governance call. And you can see the community calendar that you could add to find those ongoing calls. In addition to that, feel free to find us on Slack. You can reach out to Deep or myself, Galen, on either of those Slack channels that we mentioned, or you could just post publicly in those Slack channels and the community can help answer your question. We hope this was a useful start to getting storage providers connected with those verified clients. So with that, happy sealing, and we'll talk to you soon. Thanks.
Great. Thank you so much. So as some of you have seen, Galen is part of the foundation. And if you have any other questions, please reach out to the Slack channels that he mentioned here. Also, let us know if I saw a hand go up somewhere in the start of the meeting. If there are any questions, please post them in the chat. Even though Galen is not here, more than happy to follow up with any outstanding questions in today's meeting. All right, so let's go to the next section. So next on the agenda is NVIDIA. So we talked about some of the architectures in the past, reference architectures in the past. As everyone knows, we don't want vendors to come in and just pitch their products. We need to see a real reference architecture and how it works and what the value is for you as a storage provider in adopting some of these technologies. So today we will share with you what NVIDIA has to offer, and we have someone from NVIDIA on the line if you have any questions. Chen Long is on the line, so please post any questions if you have so, and I will start the recording right now. Give me 1 second, and there we go.
Hello everyone, I'm Chen Long, and I'm Senior Marketing Development Manager of NVIDIA. Today, my topic is a new architecture about InfiniBand SSD pooling for Filecoin. At present, most of the players use all-in-one or C2 separation solution. No matter what kind of solution is used, there will be CPU and GPU and SSD in the same server, which can handle the business flow of pre-commit 1 and pre-commit 2 at the same time. Although there are major solutions, after our analysis, there will be some restrictions on the architecture level to further improve the performance. First, since only a limited number of SSDs can be placed on the server, the bandwidth of the data placement will not be high enough. Second, since the huge data in two stages need to be processed by the same CPU and memory, the computation of the data stream will cause the overall performance to drop significantly. Third, obviously, the performance of pre-commit 2 corresponding to GPU will not match the pre-commit 1 performance corresponding to CPU, resulting in a lot of performance waste. The above is about the analysis of performance. Let's look at the problem of the cost. In this picture, because pre-commit 1 is a single-task serial processing, multicast parallel processing, and pre-commit 2 is single-task parallel processing, multicast serial processing. As a result, the time for SSD to store the data becomes longer and the utilization rate decreases. If pre-commit 2 can perform parallel processing after pre-commit 1 complete data analysis, it will greatly reduce the application of SSD. But this requires more GPUs to be placed in a server. It is not economical and there is a lot of cost waste. However, if we change our thinking and look for a solution from the perspective of the network, it will reduce the SSD occupancy. At the same, the utilization rate of the GPU will not decrease, but also will increase significantly. InfiniBand is the better solution to deconstruct the Filecoin ceiling cluster from a network perspective. As a system-bus protocol for interconnection between devices, InfiniBand can perfectly provide end-to-end 100 Gbps, 200 Gbps, and 400 Gbps bandwidth without any packet loss. So, the SSD can be easily separated from the same server with the help of InfiniBand. And then the CPU and the GPU can naturally also be separated. Yes, we can realize pre-commit 1 and pre-commit 2 separated without any data copy by the InfiniBand SSD pooling solution. Pre-commit 2 just gets the data directly from SSD server. After the pre-commit 1 server transmits the data from memory directly to the SSD server. Based on the help of native RDMA, any data transfer between servers will not consume CPU computing resources, realizing high-performance data transmission. This picture shows the effect of SSD pooling. By configuring RAID 0 on the storage side, the data transmission bandwidth can be increased by an order of magnitude. At the same time, the software divides the storage capacity of each computing node, which can greatly increase the utilization rate of SSD, thereby reducing the cost of the SSD in the cluster. Therefore, from this perspective, the SSD pooling solution is a high-performance and low-cost solution. Obviously, when SSD pooling is separate from the server, pre-commit 1 and pre-commit 2 are naturally separated, thus avoiding a large number of data streams competing for CPU and memory resources on the computing node, improved the computing performance of the cluster. We did FFDW tests on the two solutions to compare the differences. The picture above is an integrated solution, and the picture below is an InfiniBand SSD pooling solution. It can be seen that the integrated solution has a write performance of only 200 Gbps, and when reads and writes exist at the same time, the write performance will reduce to 8 Gbps, which is serious affects the performance of computing. And after adopting the InfiniBand solution, not only the performance of the reading and writing can reach close to 100 Gbps, but even when the reading and writing are present at the same time, it will remain at almost the same level. So, this is the vital reason why it can keep a higher performance. Okay, let me introduce the two sets of measured data with our partners. The first one is obtained by Keystore based on our InfiniBand solution in a 32 GB sector size. The CPU is 2 AMD 7302. Memory is 2 TB. The GPU is RTX 3080. The performance of the pre-commit one is 7.09 TB per day, which is nearly 13% higher than the 3-2 separation scheme. And the performance of pre-commit 2 is 5.1 TB per day, which is higher than C2 separate scheme by 36%. The second case is obtained by the sync chain based in information solution. The sector size is 64 GB. The CPU is 2 AMD 7543 and the 2 TB memory. GPU is 3060. Under the InfiniBand solution, the performance of pre-commit 1 is 7.2 TB per day, which is increase of 13% compared to C2 separation. And the performance of pre-commit 2 reach 3.1 TB per day, which is increase of 10% compared to C2 separation. This is a very amazing data. In addition to the above-mentioned points, InfiniBand had another advantage. As shown in the figure, as long as the rhythm of each CPU server in the cluster is adjusted, it can realize the parallel processing of pre-commit 2 tasks after any CPU completed the pre-commit 1 tasks. Therefore, make the SSD utilization rate is raised sharply and further reduce the cost. In addition, we know that during the pre-commit 1 process, the capacity occupation of the SSD increased linearly with time. If in the integrated solution, the capacity of any server SSD must be greater than the maximum consumption of the SSD during the pre-commit 1 process. But After using InfiniBand solution, pre-commit 1 can be started one by one. In this way, the consumption of SSDs by the cluster at any one time must be less than that of the integrated solution, which can theoretically save another 50%. As we know, in the actual application process, need us to switch models between 32 gigabit and to 64 gigabit. For some schemes used by miner, the performance changes of CPU and GPU in different models don't match. This requires adding and deleting components to keep the computing performance matching. Each device requires at least 1 hour to complete this task. For InfiniBand SSD pooling solution, this only requires software adjustment. No matter how large the cluster is, it only takes a few minutes to complete, which greatly simplifies the workload. Okay, to summarize the advantage of InfiniBand SSD pooling solution. First of all, SSD resource can be software defined, making it easy to maintain and manage. At the same time, with SSD pooling, CPU and GPU will also be pooled, which facilitates cluster switching and expansion. The second point is to break the SSD I/O bottleneck. The InfiniBand solution allows each computing node to obtain a larger data bandwidth, reduce the transmission time, and achieve the purpose of improving computing performance. The third point, InfiniBand's native RDMA technology can help the CPU to reduce the workload during the data transmission process. Since the SSD is separated from computing node, this will greatly reduce the CPU consumption to the pressure of data writing and reading, thereby achieving the purpose of releasing more computing resource. Fourth point, cost reduction. There are two main aspects. One is that computing power of CPU and GPU has been greatly improved, so that the hardware purchases cost under the same computing power will be reduced. But due to the new architecture, the utilization rate of SSD has been greatly improved. Under the premise of the same performance, adopting the InfiniBand SSD pooling solution will save more SSD procurement costs. Finally, InfiniBand SSD pooling solution will be balance the computing power of CPU and GPU and get rid of the waste of computing power. That's all of my presentations. Thank you.
Oops. All right, thank you so much. If there are any questions, please add them in the chat. We have the NVIDIA team here available today to answer any questions. In the meantime, I will let's move forward to the next topic. The next topic for today is StorSwift that is going to present an update on how they leverage Intel processors, some of the latest Intel processors in their architecture. So give me 1 second. I will bring this up. There we go. And share it with the team. And we also have person from StorSwift on the line. So if you have any questions, please add them in the chat. And here we go.
Hello, everyone. I am Leng from StorSwift. I am very pleased with the invitation of Protocol Labs and Intel to share Filecoin software optimization based on Intel hardware platform. At first, let me introduce StorSwift. StorSwift is a storage solution company which provides professional storage products and solutions. Our core team is focusing on enterprise storage systems for more than 15 years. We provide enterprise-class distributed storage systems. We provide IPFS and Filecoin optimization and storage provider solutions. We also develop Web3 ecological data storage DApps. And then let me introduce StorSwift Filecoin cluster solution. We rewrite the worker task scheduling code, and it can support hundreds of workers which are working at the same time, providing a continuous and stable increment in computing power. We have performance optimization for POIP and POST. For pre-commit phase 1, there is a brand new working model to improve the throughput. For pre-commit phase 2, we have I/O performance optimization and GPU code refactoring. For commit phase 2, we have implemented Snack SaaS platform. For Windows PLST, it's very fast to get the proof of one partition, and Windows PLST can be scheduled to sitting workers to save cache without dropping power. Based on enterprise-class storage software, we provide a stable storage solution to support high stability and high performance. It's easy to maintain. We also have optimized DevOps software and professional management process for DevOps. Most important of all, we have Filecoin cluster security solution to protect the security of wallet and the cluster. Intel is a great company with many excellent products, and we have many choices for Filecoin optimization-based Intel hardware. In order to improve the sitting performance, we can use the latest Ice Lake CPU with SHA 256 hardware support and AVX 512 instruction sets. To get a stable and cost-effective storage solution, we can use several series of CPU, from Delverton to Xeon D and Xeon Silver. We are able to use the surprisingly persistent Optane memory in order to obtain more memory space at a lower cost. And we have better SSD solutions and Ethernet solutions too. We all know that in the Filecoin seeding algorithm, the most time-consuming phase is phase 1 of pre-commit. For each sector, there are billions of SHA 256 hash function calls. Intel Ice Lake CPU supports SHA 256 hardware acceleration to achieve high performance of pre-commit 1. And some steps during SHA 256 calculation can be optimized by Intel AVX 512 instructions to get better performance because of concurrent data processing. Intel also provides a library to support SHA 256 optimization easily. Integrated with this library, StorSwift also rewrites pre-commit 1 code to get better performance. We use different ASIC CPUs to run ceiling tasks. For 32 GB sector, it takes around 160 minutes to finish pre-commit 1, and for 64 GB sector, it takes around 320 minutes. This performance has met the needs of large-scale ceiling tasks. We can use Intel Optane persistent memory to get a cost-effective solution. Optane SSD is much faster than normal NVMe SSD, but Optane persistent memory is even more exciting. With smaller size DDR4 memory, we can build the configuration with larger physical memory capacity. For example, we can use 2 TB Optane persistent memory with only 256 or 512 GB DDR4 memory. And the operating system can access 2 TB physical memory space. We can run more pre-commit tasks with this configuration. Optane persistent memory is cheaper than DDR4, and there is less than 10% performance loss with Optane. We can build a stable and cost-effective storage solution with Intel CPU. There are several series of CPUs to choose. From the test results, we can see for NAS storage with normal I/O loads, Intel, Vervaet, D&D, and Silver processors can all work well. Vervaet has a higher cost performance. For distributed storage based on algorithms such as erasure coding, requires D&D or Silver processors due to a higher CPU requirements. Our hardware server partner, April Cloud, provides several series of storage servers based on this Intel CPU, and they have been already running in the production environment. We also have several plans based on Intel solution to get higher performance in the future. Intel provides an excellent open source library, SPDK. It supports user mode storage applications for NVMe SSD with high performance and low latency. It can get better I/O performance for pre-commit tasks. For Optane persistent memory, if using app direct mode, it's easy to get high availability and less downtime. It can be used to build faster storage solution. We believe that we can build a better Filecoin solution with Intel hardware platform. StorSwift will continue to do the technical optimization for Web3 platform and applications. Thank you for so much for listening to my sharing.
All right.
Thanks.
Thank you so much. And if there are any questions, let's have a look in the chat here. I don't see any immediate questions, but if any would come up in the future, or if you're listening to this recording after the fact, not live, then don't stop. Reach out on our GitHub community page or contact us on the Slack channels. All right, so that was it for today. More is coming in the next month, but again, always open for your suggestions, inputs, and as always, we welcome everyone to the table that has something to contribute to the overall community. Consider this a community meetup where we can address any topic that we feel is contributing overall to the bigger community. So thank you everyone for today's attendance, and looking forward to the next one.